Hi, in this short session we are going to go over the kinematics regarding projectile motion by solving an example problem. Okay, now we have the following setup. Suppose this is the ground level and we are shooting a crossbow, and here is our target, and we are aiming horizontally and we send it with some initial speed like this, and as it turns out this arrow lands on at a point that is below the aimed location, and we are at a distance r, let's say away from the target. Okay, now we are given d equal to 30 centimeters or 0.300 meters, correct to three significant figures, and we are at a distance 40 meters from the target, and of course we have the gravitational acceleration g in the downward direction, where the value of g is 9.81 meters per second squared. Okay, with this setup we are going to find the value of this initial speed of this arrow. Okay, now let us start with a reference frame, a coordinate system. Suppose to the right is positive x and upward is positive y. So the origin is right below the initial point of the arrow that we are sending through the crossbow. Okay, now let us consider motion along x and motion along y separately. Along the x-axis we don't have any force, so we have constant velocity motion, and along the vertical axis or the y-axis, due to the gravitational acceleration and since we are near the surface of the earth, we have constant acceleration motion. Now this allows us to write the following. For x we have x of t equal to the initial position with this given reference frame plus the x component of the initial velocity times t, and for y we have the initial position y0 or the initial height plus the y component of the initial velocity times t plus 1/2 times acceleration times t squared, and here acceleration is equal to negative g. It is negative because we are assuming that the positive direction, the upward direction is positive. Okay, now with this given or with this assumed coordinate system, we have x0 equal to 0, v0x equal to v0. Okay, y0 is not 0, so let's define something. Let's say this height is h, and as we will see it will not matter, so let's just call it h for sake of simplicity, and we have v0y equal to 0 because the initial velocity has no y component, and we have a equal to negative g. So with that, we have x equal to v0 t and y equal to h minus 1/2 gt squared. And now we know everything about the motion of this object. Now let us consider the x equation, and let us focus on the point when this arrow hits the target. So at the end of the motion of this object, let's say when t is equal to t flight or t final, we will have x equal to r. So okay, we have r equal to v0 times the final velocity. We can solve this for t sub f, and we find r over v0. Now with that, let us focus on the y equation and see what happens if we evaluate y at t equal to t sub f. Okay, we have h minus 1/2 g r over v0 squared. So we have h minus g r squared over 2v0 squared. Now at the end of the motion, our object is here at a height given by h minus d. So this guy must be equal to h minus d. Okay, now let us focus on this last equality. We have some nice cancellation between these h terms, and then we can cancel out the signs. So we have g r squared over 2v0 squared equal to d. And if we solve it for v0, we find plus or minus square root of g r squared over 2 times d. And at this point we are going to take the positive root, because this is speed and speed is always positive. So we have square root of g r squared over 2 times d. And if we plug in the numbers correct to 3 significant figures, we are going to obtain 162 meters per second squared. So in this exercise we have seen how we used different types of equations of motion for these different motions: constant velocity motion along the x-axis and constant acceleration motion along the y-axis. There is no force along the x-axis, so with Newton's second law we have no acceleration, and there is the gravitational acceleration in the downward direction for the motion along the y-axis, so we have acceleration equal to negative g. And using the given information, step by step we eliminated some of the variables, which is time to begin with, because we don't deal with time here, and we have arrived at the conclusion that the initial speed of this arrow is 162 meters per second. And with that, I think we can conclude our mini session where we have reviewed the kinematics of projectile motion. Okay, that's all.